Alright, well, I've made a few videos on these rotary screw compressors, but I've never really explained how they work to people that aren't in the field, and there's not a lot of people in this field. So I finally found a situation where it's not noisier than hell and I can kind of talk a little bit, so I think this would be a good opportunity. First off, we'll start out with this tank right here, which is known as the oil reservoir or the sump tank. Its purposes are to hold the fluid, and it's also a small little air reservoir for the controls and stuff of that nature, just so we have a place to build air pressure inside the system. So basically, the oil is used for three things in a rotary screw compressor. One is lubrication, the next is cooling, and the other is sealing or lubrication. So basically what you have here is a helical cut rotary screw compressor. It's got helical rotors in it. It's kind of like what's in a supercharger, if you will. Oil is injected into this point right here, and there's some small little orifices on the bottom of the housing right here, which basically shoot the oil into the rotor housing, and which gives you your sealing. So then what we have once the compressor is turning is a discharge of air and oil that comes through what's known as the discharge line right here and enters into the sump tank, and it looks like it just goes right in the side of that tank, but there's actually a baffle inside of the tank. And basically what happens is the discharge of air and oil is separated through gravity, and the oil falls to the bottom and the air oil mist goes to what's known as a separator element, and that is what is housed in this flange on the top of the sump. This particular unit has dual separation, and these are what's known as the scavenger lines. They go to the bottom of the separator element. You can see these stainless lines right here. They go to the bottom of the separator element, which has a pan on the bottom of it, and basically this is distributed to a low point, a low air pressure point inside the pump, or it sometimes goes back to the inlet under a vacuum situation, and that's where the oil is returned. So that's what keeps the oil in the compressor, otherwise it would go downstream. Although you got to keep in mind, all rotary screw compressors, oil flooded rotary screw compressors for that matter, all will pass a little bit of oil downstream. Alright, so once the compressor is up and running, it starts to develop air pressure, and we have what's known as the heat of compression, and that's where the cooling comes in with the fluid. So basically what happens is as the temperature rises inside of the compressor itself, it's sensing it in this thermal valve right here, and this is a fluid diverting valve. It diverts the fluid from either the cooler or around the cooler and bypasses the cooler till it gets up to about 175, 180 degrees, somewhere around there, and that's a normal temperature on a rotary screw compressor will be about 100 degrees over ambient. And then of course, this being our main fluid line going in, we filter the fluid. I know it's upside down in most cases, but it actually still works the same way. This is an air-cooled unit, and so it's fan cooled, and inside of here there is actually two coolers. There's one for the air side, so it would be an after cooler, and then one on this other line here is the oil cooler line. Two kind of designs with rotary screw compressors. One is load unload, and the other is modulated. This machine is modulated, and basically it'll match the demand for the plant air pressure, providing you don't drop or use more air than what the capacity of the compressor is. Here we have all the controls like I had mentioned. This one is Y delta start, and as you can see with the three starters right here, it has basically a start and run configuration. I can't stand it, but it is what it is. Any Y delta start has got to be a loadless start. So on these rotary screw compressors, when you start them up, especially on these American-made machines, they want to make air right away because the inlet valve is wide open, basically. So what we do in this situation here is we've got a little pressure reservoir right here, and you can see the pressure on that glycerin filled gauge. It doesn't look so good, so it just houses pressure in here, and if you were to break the line to the inlet right there, you would have air pressure, and that's just keeping the inlet valve closed for starting purposes only. And then this is our regulator to modulate the compressor or to throttle the air to meet the air demands. And then basically we have a full load solenoid valve here if we want to take in, oh, excuse me, this is the load unload solenoid valve, I'm incorrect. This is the full load solenoid valve. If we want to get this machine to run in sequence with another machine and get this machine not to modulate and run wide open, this valve comes into play. Although it's had some problems with some crap inside here and the guts are missing and we're not sequencing it, so we really don't need it. Here we are on the top of the sump tank, or the air reservoir, whatever you want to call it, or oil reservoir rather. There's a spring-loaded check valve that all the air goes through. It's called the minimum pressure check valve, and it's set for about 60 psi, and it's designed so that if you start the compressor up and there's no air pressure in the plant, it'll maintain 60 pounds of its internal pressure. It's because it's used for lubricating the pump, and there is no oil pump here, so we have to have at least a minimum of probably 20 pounds, 30 pounds of pressure just to move the oil. Like I said, I think I just got done replacing the motor here. This is why Delta Start, and I don't deal with too many of these, and I actually have the coupling element disassembled right now because I'm a little bit concerned that when you start this, if it's not wired right from the factory, it's going to try to go the direction it's supposed to go in start, and then when it goes to run, it might have the tendency to go backwards. So it's bad enough that happens with the motor, let alone the pump, so I have this all loose right now. And the coupling is out of it at the moment, so just got to get her back in the room and I'll get it running and get a video of it running, and that'll kind of be about it. Thanks for watching, guys. Alright, when the motor failed, it took out these two contactors right here, and that was a costly endeavor, not for me but for the end user. And what I got right now is I don't have any power out here except for what I got here. I got this little inverter right here. I'm right by my vehicle and by the van, or by the compressor rather. The contactors were replaced by an outside contractor, so I just wanted to make sure that these things are going to be alright. So I got some temporary power hooked up here with a little circuit breaker gimmick right here. This thing works awesome for like testing coils, and anytime you got a situation where it's blowing a control fuse, it's so easy just to use this and just disconnect coils until you find the problem. At least that's what I found the best. So at any rate, I'm just going to kind of dry fire this thing, the starting gear at least. See, I got a good display here, so everything should be good. Let's see, here we go. Like one contactor is buzzing a little bit, and it's going to shut right down on a little sump pressure because it thinks it's running, but it ain't.